Well, I am so excited to welcome you to week 2 of our time together in this journey into agents land. And as well you know, week 2 is all about OpenAI Agents SDK, formerly known as Swarm, released very recently, the newest of our arrivals into the agents framework land, and one that I cannot wait to tell you all about. But first, isn't there always a but first? But first, before we can do OpenAI Agents SDK, I have a sidebar, a topic that I have to cover with you, a very important topic, and it's to talk to you about asynchronous Python, Async IO. It's something which is common across all of the agent frameworks. So all of them make use of asynchronous Python. And it's something which you can get by without really understanding. There's a couple of rules that you can learn, and then you just follow those rules always, and it will just kind of work, and that's okay. But I'm here to tell you that that's unsatisfactory, and that it's much better to just take half an hour to get to the bottom of this, to really understand it, to thrash it out until you're like, okay, I get asynchronous Python. I understand it. And if you do this, if you take the half an hour, you will thank me. It will again and again, you will come across this and you will be completely comfortable with it. And it's only half an hour. And so I put a guide in the guides that will take you through this so that you can be left with no questions in your mind at all about what it means to write asynchronous Python. And I'm also now going to cover it just very briefly at a high level. Let's talk Async IO. Well, look. First of all, there is like a short version, a simple version. This is what I mean when I say you can get by without really understanding it. So Async IO is a way of writing Python code, which is a kind of lightweight version of multi-threading. So many people from a software engineering background will be familiar with the idea of multi-threading. When you write code that can run concurrently, you can have multiple threads which are each executing code together. And there's often a lot of baggage that comes with that, some sort of framework stuff that comes with it. Well, Async IO, which was introduced, I think, in Python 3.5, is this very lightweight way of doing it, which doesn't actually involve threads at an operating system level. And it also doesn't involve what's called multi-processing, which is when you spawn multiple Python processes and they all run together. This is another way of doing it that is super lightweight. And because it's super lightweight, it means that you can have thousands or tens of thousands of these things all running without consuming much resources at all. So it's a simple, easy peasy, lightweight way of writing code that can run concurrently. And particularly, it's good when you have code that makes use of input-output, like waiting on networks. It allows other things to be running whilst one bit of code is waiting on network. And when you're running LLM requests, you're mostly, if you're using paid APIs like OpenAI, most of the time is being spent waiting for stuff to feed back from a model running on the cloud. So there's a lot of waiting on networks, a lot of IO-bound waiting. And as a result, asynchronous code is great to use. And when you're thinking of multi-agent frameworks, when potentially you have lots of these all hitting different paid APIs, it makes so much sense to be using it. And that is why all of the agent frameworks we'll look at use Async IO. Okay, so with that preamble, this is the short version. The short version is Async IO is actually two things. It's a package called Async IO that you can import, and it's also some language constructs baked into Python. And those language constructs include two keywords that you see right here. And one of those keywords is the word async. And anytime that you have a function which is potentially going to be able to run in a way that allows other things to happen concurrently, you simply put the word async before it, like this: async def do some processing. So def do some processing becomes async def do some processing. That's how you say this is a function which can run asynchronously. And when you call that function, you don't just call do some processing like you're used to. You have to put the word await before it. So you say await do some processing. And if do some processing returns a string, then you can't just say result equals do some processing. You have to say result equals await, do some processing. But otherwise, it's just the same. So that's the short version. And if you wanted to get by without really understanding it, you could just follow those rules and keep going, and it might be enough. But now let me tell you the bigger story. Okay, now we're going to go a little bit deeper and talk about the real story with Async.io. So look, as I say, it's a lightweight alternative to multi-threading or multi-processing. Something like multi-threading is implemented at the OS level, and it supports concurrent execution of different programs where at the CPU level, it's being managed to sort of switch between these two programs and treat them as if they're running at the same time. This is different. In the case of Async.io, so there are some special keywords. There's this keyword async. If you define a function as async def, and then the function, instead of just def, the function, then this thing is no longer actually called a function. It's known as a coroutine. Now, most people still use the word function. You'll hear me saying function, but strictly speaking, anytime you see async def, you should say, okay, that's not a function, it is a coroutine. And that means it's something special that Python can pause and resume. When you call a coroutine, it doesn't run, unlike any other function that you call that does run. When you call a coroutine, it just returns a coroutine object, but nothing is executed. To actually run that coroutine object, there are a few ways to do it, but the most common one, and the one that we will use all the time, is to await it. So you say await, and then the coroutine object, and that schedules it for execution. What does it mean to say it's scheduled for execution? Well, there is this piece of code written in the Async.io library, which does what's known as an event loop, which means it's a kind of while loop that sort of iterates, and it takes this coroutine and it starts executing it. And it can only execute one coroutine at a time. It's not like multi-threading. It's going to be executing this coroutine, except if this coroutine gets to a point when it's stopped and it's waiting for something, like it's waiting for I/O, perhaps it's made a call to OpenAI and it's waiting for OpenAI to respond. At that point, the event loop can put that on pause and start executing a different one of the coroutines that's in its sort of list of coroutines waiting to be run. And if that hits a point when it's waiting on I/O, then the event loop can run another one, or it can continue the first one. So it's a sort of manual way of handling multi-threading. It's a manual approach to implementing multi-threading, but only really working when something is blocked waiting on I/O. And because of this, because it's sort of written at a code level and it's super simple and very easy to understand, it's also lightweight. You can have thousands or tens of thousands of these things. And so it's really easy and quick to get this running. And that is why it's so popular. And that is why it's used so ubiquitously across agentic frameworks. So I hope obviously I've only given you a bit of detail here, but I hope that gives you some perspective on what's going on. And when we look back now at this, you can see that whilst a simple interpretation is just to say, okay, whenever I use async, I've got to use await. The deeper interpretation is to understand that when I say async def do some processing, that's no longer a function. It's now a coroutine. Do some processing, we need to call await do some processing in order to schedule that coroutine. And that is now blocking until that completes, and the result will go into that variable result. I hope that made some sense. But if not, as I say, there's a whole guide. You should go and look at the guide now. And so just to beat this one to death, I'll give you a couple more examples, and then hopefully you've really got this. So look at this again. This is back to the async def do some processing. It's going to do some work, and then it's going to return the string done. If I just say like my coroutine equals do some processing, you might, if you didn't know already about this, you might think that will run do some processing, but of course it will not. It will return a coroutine object, and that's what will go into the variable my coroutine. In order to actually run it, you have to call await. So you'd say my result equals await my coroutine. It's now going to run, and the result, the string done, is going to go into my result. So that is the point. That's how it works. And of course, you don't need to it's simpler than that. You can just say my result equals await, do some processing, which is what we always do. And then just to hopefully sort of connect the dots to make this really click for you, there are other constructs. You don't just have to call await and then the name of a coroutine. Because if that's all you could do, you might say to me, okay, hang on, but in that case, there's nothing concurrent happening here. Every time I call await and then a coroutine, it will block until that finishes, and then it will go on to the next. Well, there are a few other constructs in the Async IO package that allow us to do more interesting things. And this is one of them, and it's one that we will use this week in our code. And it's where you can say results, plural, results equals await, and then call this function asyncIO.gather. And you can then pass in multiple coroutines. And I'm sure you can imagine what happens, but the event loop is going to schedule all three. And as soon as one of them is blocking, the others will start running, or one of the others will run until it's blocking, and then the third one will run. And so all three of those coroutines will execute, and the results as a list will go into the variable results, a list of each of the three results from each of those three coroutines. So in some ways, it's kind of fake multi-threading. It's sort of brute force multi-threading. It's multi-threading not at the operating system level, but multi-threading implemented almost manually with this event loop and just handling things like IO blocking and being able to schedule the next one. That's how to think about it. Okay, enough with the sidebars. It's on to the main business. It is on to introducing OpenAI Agents SDK. Now, let me start by teeing this up. So this is a framework which, as I've already mentioned, is super lightweight, very flexible. One of the things I love about it is that it's not what they call opinionated. Opinionated is how some frameworks are described when they come with a lot of constructs, a way of doing things that you are then sort of expected to adhere to. Now, that's not always a bad thing, because that can help build particular design patterns. It can allow you to build things really, really quickly. But my personal bias is I often prefer things that are less prescriptive and which give you more flexibility to choose how you want to work with this. And very much OpenAI Agents SDK is of that ilk. It also is very good at the same time at making some of the everyday stuff, like using tools, much simpler. So if you think of all of that gunk that we had to do with the JSON around tools, all of that faffing around with big JSON objects, well, OpenAI Agents SDK just does all that for you. So that kind of stuff is it is in the way, but in a good way. It just does all of that JSON stuff, and it handles if you remember the if statement and then my fancy version of it, it does all of that so that you just don't need to worry about it. And that's one way where it is good to have some abstraction, because that's the useless boilerplate stuff that you have to repeat every single time that you want a framework to do for you. And as you can probably tell from the way I'm saying this, OpenAI Agents SDK is my favorite. And I'm really looking forward to this week, and I enjoy working with OpenAI Agents SDK. And you might be thinking, Ed, why are you showing us your favorite one first? Why don't you want to end with your favorite one? You should work up to it. And I have two answers for you there. So first of all, I do want to point out that whilst OpenAI Agents SDK is my favorite, all of the frameworks are great, and they all have pros and cons, and each of them have use cases where they are the best for that particular kind of problem. So in some ways, they're all my favorites, but no, that's not true. OpenAI, you're my favorite. They're all good, and so but they also get that during the course of our journey, they're going to get more and more complex, and so it's going to make sense to do it the way we do, and our projects are going to get beefier and beefier. So that's the first reason. The second reason is that whilst this is the framework that we are starting with, we are also going to finish with it as well. Because in week 6, when we work with MCP, which is a protocol, not really a framework in the same way, we are going to be using OpenAI Agents SDK again in a more hardcore way. So it's going to come back. It's going to make a triumphant return in week 6. So you don't need to worry. The crescendo will be there. Now, one thing that all of the frameworks have in common is that they come with some terminology, some constructs, and each one is, of course, slightly different, and we will be learning each of the different terminologies as we go. But of course, OpenAI's terminology is pretty minimal. It's fairly simple stuff. There's three concepts, three terms I'm going to go through with you. The first of them is just an agent. Agents represent their sort of package around calls to LLMs which have a particular role, a particular purpose in this solution, obviously. Handoffs, this is their name for the interactions between agents. So handoff is a term that they use a fair amount, and we'll see it come up in different contexts, but that's what it means. It is an interaction. And guardrails is their terminology for the kinds of checks and controls that you put around making sure that an agent is doing what you want it to do and isn't going off the rails. Guardrails is a pretty common word in normal software engineering anyway, but it's one of the three terms to take on board for using OpenAI Agents SDK. So in order to actually run an agent, there are 3 steps that you have to take. And here they are. Here are the 3 steps. You create an instance of agent. It's going to be the thing that you're going to set up to be one of the roles in your solution. You use something called with trace to be able to keep a log of all of your interactions with that agent. This isn't required, but it's going to be the way we will do it, and we will always do it this way. And it's going to allow us to look in OpenAI's monitoring tools and see everything that's going on. And then you call something called runner.run. And runner.run is the thing that will actually run the agent, as you will see. And runner.run, the thing that actually runs the agent, is, of course, an async function, or I should say it's a coroutine. And so as a result, it's something that we will need to await in order to get it to actually run. So we were going to need to do something that's going to look like await runner.run. And these are the 3 steps. And without further ado, let's go and do those 3 steps right now. Welcome back to Cursor, where we are ready to go with OpenAI Agents SDK. So you'll see that we have the folders on the left here, the directories, and we are now going into number 2, OpenAI, and into lab number 1. Here it is. First look at the OpenAI Agents SDK. I've included a link to the docs for OpenAI, and I will say that it does almost concern me showing you these docs because they're so clearly written and so easy that I rather wonder what my job is in all this. I will say that for the next few weeks, I think I definitely have a job. It gets a lot harder. But for this one, you'd be doing well just to read the docs and it'll be very clear to you. So anyway, I'll keep going regardless. So let's do some imports to get us started. So we will say from .env import load.env. We know we got to do that. And now we're going to do some imports from OpenAI's package. And their package is called Agents. And from that package, we're going to import Agent. We're going to import this thing called Runner. And we're going to import this thing called Trace. These are the 3 things I told you about that we were going to use today. And the OpenAI package is called Agents. That's the one. I do sometimes think that it's a bit strange that they use such a generic name for it, because I imagine a lot of people use the name agents for their own packages. I often do. And so you have to then start messing around with different kinds of imports. But still, they did. It's called agents. And this is how we import these 3 key things: agent, runner, and trace. All right. So the usual starting point, hopefully this is second nature to you. We need to run load.env with override is true to bring in our environment variables they are in. Okay, we are now going to make an agent. We're going to create our first agent from a framework of this course. And so we're going to have an agent and say agent equals. It's going to be an instance of the class agent. So we're creating an instance of agent, OpenAI's class. Now it has some parameters we need to use, some arguments. And one of them is name. We give it a name and we're going to call it the jokester. And then we give it something called instructions. I like the way Curtis just filled it in. I'll just press tab. Put me out of my misery. So we pass in some instructions. The instructions are basically the system prompt for this call to LLM. So each of these agents you can think of as being an LLM with one particular system prompt designed to organize it around one particular task. And so our system prompt, called the instructions in this case, you are a joke teller. And you also pass in a model, which in this case is GPT-4o Mini. And you might be thinking in your mind a very good question, which is, does this mean that OpenAI Agents SDK always uses OpenAI's models? That might sound like it's a sensible conclusion, but no, definitely not. The Agents SDK is very much able to work with many models, as we will later in this week explore, using different models with the OpenAI Agents SDK. It's not opinionated. You can use different models with this same framework. But by default, if you just pass in a model name, it assumes you mean OpenAI. Okay, so now we're going to execute this. And now we have our first agent. Let's just look at what it looks like. It is an agent with name, jokester, instructions, you're a joke teller, and it's got some things here. Handoffs, you remember, that was the concept that relates to the interactions between agents. It's got a model, and it's got a bunch of settings and other things that you can look at in your own time to be worth looking at. It has guardrails, input guardrails and output guardrails that we will look at later. Okay, so I mentioned that runner.run is the way to run one of these things. So we can say perhaps result equals runner.run. And when you run an agent, you pass in two things. You pass in the agent itself to be run by the runner, and you pass in what is essentially the user prompt. It is the message that you are sending the agent. Let's say, tell a joke about autonomous AI agents. Okay, so now we are going to run this. It seems pretty simple. What do you think is going to happen? What's going to be in result? I will print result. Let's see what we get if we do this and we print result. Let you have any ideas? Here it is. We get a coroutine object because runner.run is an async method, which means an async function, which means that it returns a coroutine object. It's not a function, it's a coroutine. And so hopefully you're expecting that, or you guessed. What does that mean? That means that we can't just call runner.run and expect that to work. We have to call await. And I'm going to restart this kernel and start again from the top so that we don't have one hanging out there, not scheduled. We will come through. We will do this. We will create our agent. And there it is. And now we're going to say await. We're going to say results equals await runner.run, like that. And so now what we know is that runner.run, that coroutine, is going to be queued by the event loop. And when we call await, it's going to execute it, and it will hold until it's completed execution, and the results will go into the variable result. And then we are going to print result dot final output. And this is now hopefully going to work and tell us a joke. Let's see what happens. Why don't autonomous AI agents ever get lost? Because they are always following their own self-driving instructions. Okay, so OpenAI is rather better at dealing with lightweight agents frameworks than it is at telling jokes, but we'll accept it. So it works. Now you can be forgiven for saying, all right, we haven't done anything particularly special here to do with agents. All we've done is have a system prompt and a user prompt, but never fear, there'll be plenty of time for that later in the week. What we're doing right now is just showing you the basic construct. And for my final part of this, I'm going to wrap this in a trace. So for trace, you wrap this in a context manager. So I say with trace telling a joke, and then I just need to put that like that. If you're not familiar with context managers, then look in the guides, but I imagine that you are. And what this does is it's telling OpenAI that we would like it to record these agent interactions, of which there's only one, and record it under the kind of heading telling a joke. And this allows you to have sophisticated agent interactions with many different agent calls involved and have it all packaged up and available in their monitoring tools under one kind of heading. So let's run this. We'll get another joke. Why did the autonomous AI agent break up with its human partner? It just couldn't handle the emotional bandwidth. Okay. I guess it's not got a whole lot to do with agents, except it's put it in there with the human partner. That's all right. Oh, I'll let you be the judge of it. But now we can go and look at this trace. If we go to platform.openai.com/traces, here it comes. Traces. It's actually, you could just go to platform.openai.com and then just click on traces in the left. And you'll see that telling a joke is the top trace up here. And if I go into this trace, we will see what happened is that there was one endpoint called. The system instructions was you were a joke teller. That's the system message that was just called instructions. The user prompt was tell a joke about autonomous AI agents. And then this was what the assistant responded. So true to its word, it's giving us a clear trace of the single call to an LLM that happened as part of this agentic workflow, but it's packaged it up under the heading telling a joke. And this has allowed us to come into traces and see this. And as you can imagine, it's not particularly profound with this very simple example, but there will come cases in the future when this is going to be invaluable. So that concludes our very first foray into OpenAI Agents SDK. But before we wrap up week 2, day 1, I did want to have a second sidebar with you. And this time it's on the entertaining topic of vibe coding, which is a term coined by the legendary Andrej Karpathy, who described this in, I think it was an X post that went viral about the way that he was enjoying coding with LLMs and getting so much done in a way that you would sort of let the LLM generate some code and sort of go with it, tweak it a bit, generate some more, and just make so much progress in this sort of mode of working, this ad hoc vibe coding way of navigating around things like new frameworks. So I think this is wonderful, and I strongly encourage vibe coding, and I imagine that most of you are very good at it. I did want to give a few tips that I think are important to do it well, because I think it's easy to do vibe coding and to get led astray by LLMs and get yourself in trouble and get stuck, which is very unpleasant. So I have 5 tips to leave you with, but before we get into more detail with OpenAI Agents SDK, and here they are. First of all, good vibes. It's important to spend time getting your prompt to the LLM to be really good, that you can reuse lots of times. You should ask for short answers. LLMs tend to be quite verbose in the way that in their code that they generate. They like packaging everything with lots of exception handlers, and they tend to do things in quite long-winded way. Try and ask it to come up with concise, clean code. And also mention today's date and say, please make sure that you use APIs that are current as of this date. Otherwise, LLMs have a nasty tendency to use older APIs because that was in a lot of their training data. So explicitly prompt for that. Vibe but verify. My second tip. Don't just ask an LLM a question and go with it. Ask a couple of LLMs. So I often ask the same question to ChatGPT and to Claude, and I have them both up. I ask the question because I'll learn from both of the answers. Often one of them is too long-winded or is missing the point a bit, and one of them will be spot on. And so asking a couple or maybe even 3 so that you're verifying what answers you're getting is a really good technique. Step up the vibe. So this is saying, and I think this is such a great one. This is because I sometimes get students sending me problems. They're saying, I'm stuck with this, and they'll send me some code, and it will be like 200 lines of code. And they'll say, it's not working, I don't know why. And when I look through the code, it's immediately obvious to me that they've been vibe coding. You can tell there are telltale signs that a lot of this was generated by an LLM. And it's unwieldy, and I can sometimes see a bunch of different bugs in it. And I come back and I say, it's no good. It's no good generating 200 lines of code and then saying it's broken. That's not the way to do it. Rather, you should always try and get LLMs to do things a little piece at a time. Generate function by function, generate small pieces that are independently testable, like 10 lines of code at a time. So you should think of dividing your problem down into small bite-sized chunks and have an LLM do each piece of it. And here's the trick. If you can't think about how you would divide your problem down into 10 smaller steps or whatever, you don't need to, because you can ask an LLM to do that. But be very clear, you don't want it to generate code. You say, look, I'm trying to solve the following problem, and you tell it, and say, what I want you to do is tell me what would be the 4 or 5 steps in a solution where each step is simple and a simple bite-sized chunk that could be tested and verified independently, and get it to come up with those chunks. And then you can ask again LLMs to generate code for each one in turn, along with the way to test it, so that you can make sure that 10 lines of code at a time, you have a working solution. And you've convinced yourself that when you've got each of these, you'll be able to put it together and have 200 perfect lines of code. Okay, and then the fourth one, vibe and validate, similar to vibe but verify. But vibe and validate is saying you can ask a question to an LLM, and then when it gives you the answer, you can go to another LLM, or even the same one, but better to be another one, and say, I asked this question, I've got this answer. Please confirm that that is an appropriate answer and that you can't do anything that's more concise or better structured or clearer, or there are no bugs in this. And by having another LLM go through and validate, it will often detect problems or make it be cleaner and simpler. So it's just a nice trick. And in many ways, this mirrors, this echoes the common agentic design pattern of the evaluator optimizer, but you can just do that manually yourself. So taking a leaf out of agentic design patterns and using it as part of vibe coding. And then my final one, vibe with the variety, which is don't just say, can you generate code for this? But particularly if you're already talking about 10 lines of code, say, can you give me 3 different solutions to this? Approach it 3 different ways. And maybe the response will be that there aren't 3 different ways of doing it. There's only one clear way. But you might get 3 different solutions, and that will force the model into a mode where it's contemplating different ways of approaching the same problem. And as a result, you might get better solutions. As part of that, you can also ask it to explain itself, explain the rationale, so that you'll get something that will also force it to think through why it's approaching it differently. Plus, as an added benefit, it will explain to you what's going on so that you can really understand this. And that does sort of lead to an obvious point, which I've not put here, which is that when you do vibe coding, you should always then go back and ask an LLM to explain it clearly if it's not immediately clear to you. Get to a point when you understand every single thing that's going on. Vibe coding is super fun and productive and powerful, but if you're not following what's actually happening, it's going to become painful and frustrating when something goes wrong. So it is important to stay in touch with what's going on. All right, and that is my survival guide to vibe coding, and I hope you'll find that helpful. But other than that, you should definitely do it. It's great fun and it's super productive. And that's a wrap on week 2, day 1, understanding OpenAI Agents SDK concepts. Not that there was all that much to understand. And tomorrow in day 2, we're going to build our first project, an SDR, a sales development rep, and it's going to be great. I will see you there.